In our first problem, we were given a profit function for the manufacturer of a particular line of washing machines, and it's a quadratic, negative 0.1x squared plus 90x minus 5,000, where x along this axis represents the price of the washing machine in dollars, p of x is the profit. So what you can see is that when the price is set too low, the profit actually goes a little bit negative, finally gets to zero, and then the profit keeps increasing as we go toward point C, where we get the maximum profit. And then that's at around 400 something dollars. And then, well, we can see it's at 450. And then it declines until the profit goes to zero again at $840. And what we presume is at that point the washing machines are too expensive, no one's buying them. Whereas down here at point A, we presume that the washing machines, people are buying them, but they're not charging enough, so they're losing money on the washing machines, or at least not gaining any. Okay, so that's the general look of this function. It's a upside down parabola, so it has a vertex which will represent a maximum. And we're going to end up with, when we set this equal to zero, we're going to end up with two positive values for our solutions. So we'll using the quadratic formula or plugging it into your calculator, you get these two solutions of 59.49 and 840.51. So in this case, both of them make sense. Whereas with other problems that we've done, let's say where we're measuring the time after a ball was thrown or dropped, the time would always have to be positive. So when we got one solution that was negative, we rejected that. Here we can accept both positive solutions. What price would maximize the company's profit? So again, the quadratic formula program you have in your calculator will generate, as its third and fourth numbers, the coordinates of the vertex, an x-coordinate of 450 and a y-coordinate of 15250, which represents the setting the washing machine price to $450, which would generate a profit of $15,250. If we just use the quadratic formula not plugged into your calculator, we would say that in the ax squared plus bx plus c, that the x value of the vertex is, as we've talked about before, negative b over 2a, or negative 90 over 2 times negative 0.1. And again, that's because our b coefficient was 90 and our a coefficient was negative 0.1. And when we process that through, we get 450. And then to find the y value associated with that, we would plug that into our original equation. We would work that through and end up again with 15,250. Okay, the third question asks, what if the company ended with a profit of $10,000? What price must they have sold the machines at? And it says if you get two answers, pick the higher one, because again, we could and actually will end up with two positive solutions to this. So what we could see is that if we drew a line across here at y is equal to 10,000, we're going to hit our curve at two places. One looks like a little above 200 or maybe a little below, and then the other somewhere around here, closer to 700. And again, those two are going to be symmetrical around the vertex, which has an x value of 450. So each of our two values, one will be to this side of 450, the other will be the same distance to the other side of 450. Okay, so then what we do is we set the equation equal to 10,000, and then we then subtract 10,000 from both sides so that we set our quadratic equal to 0, and then again using the quadratic formula or our calculator program, we solve and we get our two solutions of 220.87 and 679.13. We were told to pick the higher one, so we picked the higher one of $679.13. And again, the profit was not as high as it could have been, because if they'd set the profit at the cost at $450 per machine, they would have sold enough extra ones that it would have outweighed the fact that you were charging a lower price. So we don't get our maximum profit here, but we do get a profit of 10,000. And we would also get a profit of 10,000 had we set the price at $220.87, in which case we would have sold more machines, but they would have been at a lower price, so we would not have ended up making as much profit. Okay, solve by completing the square. We have a quadratic set equal to a constant. So the first thing we do is we clear the constant from both sides, so we end up with 2x squared minus 8x, from just the left side. 2x squared minus 8x is equal to 5, so we added 4 to both sides. Then we're going to divide through by this coefficient 2, and we end up with x squared minus 4x equals 5 halves. We want to make this left side a perfect square trinomial, so we take the coefficient of 4, we take half of it, which is 2, and then we square that, which actually gets us another 4, which we then add to both sides. And so now we have x squared minus 4x plus 4 is equal to 5 halves plus 4. The left side can be factored to x minus 2 squared. The right side is now, we're going to set to equal to 5 halves plus 4 when we convert to halves is equal to 8 halves. So 8 halves plus 5 halves equals our 13 halves. We square root both sides. We get x minus 2 equals either the positive or negative square root of 13 over 2. And for our final solution, we add 2 to both sides, and we get x is equal to 2 plus or minus the square root of 13 over 2. Okay, number 3, solving. When we have this set up, we want to cross multiply, and we'll then get an equation which will end up being quadratic. So we have x minus 2 multiplied by 3x minus 5, and that we set equal to x plus 3 times 2x minus 6. When we work these through, we end up with x times 3x, or 3x squared, x times negative 5, which gives us negative 5x, 3x times negative 2 gives us negative 6x, and negative 2 times negative 5 gives us positive 10. On this side, we end up with x times 2x is 2x squared. We end up with 3 times 2x is positive 6x. We have negative 6 times x is negative 6x. 3 times negative 6 is negative 18. Okay, that gives us on the left side 3x squared minus 11x plus 10. On the right, 2x squared minus 18. When we want to set this equal to 0 in order to solve, and when we do, we get x squared minus 11x plus 28. This turns out to be factorable with x minus 7 times x minus 4 equal to 0, which gives us solutions of x is equal to 7 or x is equal to 4. Okay, so here we get something that has some negative exponents in it, some things multiplied. So the first thing we want to do is deal with these negative exponents. So we replace x to the negative first with 1 over x, and so when multiplied by 3, we end up with 3 over x. So remember, it's not 1 over 3x, because the only thing we're raising to power of negative 1 is the x. So we end up with 3 over x. Here we have x minus 4 multiplied by x minus 1 to the negative first. So that's really the same as saying x minus 4 times 1 over x minus 1, which gives us this thing here, x minus 4 over x minus 1. And then we also have the 2. So on the right side, we want to combine these by giving them a common denominator. So for the 2, we multiply top and bottom by x minus 1, which gives us 2x minus 2 over x minus 1. We can now combine these two fractions on the right side. We get x minus 4 plus 2x minus 2 is going to give us 3x minus 6, and that's still over x minus 1. Okay, so now we can cross multiply to get 3 times x minus 1, which is 3x minus 3, is equal to x times 3x minus 6, which when worked through is 3x minus 3 is equal to 3x squared minus 6x. We then set it equal to 0 by, in this case, subtracting 3x minus 3 from both sides and reversing the order here. And then we divide through by 3 to get x squared minus 3x plus 1. We plug into the quadratic formula, negative b, so negative of negative 3, plus or minus the square root of b squared, negative 3 squared, minus 4 times a, and in this case the coefficient of x squared is 1, although it's not written. So we have minus 4 times 1, which is a, times another 1, which represents our c value here, and all of that is divided by 2 times a. And when we simplify up top, we get 3, positive 3, plus or minus the square root of 9 minus 4, or square root of 5. And actually all of that should be over 2, so there's a mistake here. So it should be 3 plus root 5 over 2. My mistake. Okay, factor. First thing we look for is common factor. We find that all of these can be divided by 4x, which gives us 4x times 6x squared minus 7x plus 2. We want to find numbers that multiply to 6 times 2, the 6 for the x squared coefficient times the 2. And these numbers should also add to negative 7. That gives us negative 4, negative 3. So we will then split this middle term into negative 3x and negative 4x. Then we will, in the next step, we'll factor out the greatest common factor from each of the two factor pairs. So we factor out a 2x minus 1 from both, which leaves us 3x times 2x minus 1 minus 2 times 2x minus 1. And when we then distribute here, we get 3x minus 2 times 2x minus 1. So the whole thing, we can't forget the 4x. We end up with 4x times 3x minus 2 times 2x minus 1. Okay, the next one, 2ab plus c minus ac minus 2b. Again, we have 4 terms, so we're either going to be factoring by grouping, or we're going to have a combination of like a perfect square trinomial and a difference of perfect squares. But we don't have that second case, so we must use the first approach. And in order to do that, we have to rearrange somewhat so that consecutive terms have something in common. There's more than one way to do it, but I chose to rearrange it to get 2ab minus 2b plus c minus ac. And so I can factor 2b out of our first two terms, leaving an a minus 1, and a c out of our second two terms, leaving a 1 minus a. But then what I need to do is recognize that 1 minus a and a minus 1 are just the same thing, but with opposite signs. So instead of having plus c times 1 minus a, I have minus c times a minus 1. And that still works out to be the same thing as we had up here in this step. So now I see I have an a minus 1 and an a minus 1. I factor that out, and I end up with 2b minus c times a minus 1. Okay, this next one is a challenge, won't be on the quiz, but so here we have an x squared term and an x term, a y squared term and a y term. So what I'm going to do is I'm going to create two perfect square trinomials, and the reason that this works is because to create a perfect square trinomial out of 4x squared plus 4x, I have to add a 1. To create a perfect square trinomial out of y squared minus 2y plus 1, I have to add a 1 inside the parentheses, which means I'm adding a negative 1 overall, which means I've added a positive 1 and a negative 1, and so those therefore are not going to, they're going to cancel each other out, so I'm not changing the value of this. So we end up with 2x plus 1, this should be an exponent, so 2x plus 1 squared minus y minus 1 squared. So we have difference of perfect squares, so we have, if this is a and this is b, 2x plus 1 minus y minus 1, which looks like this, 2x plus 1 plus y minus 1. We end up with 2x, and we have a minus y plus 1, and then a minus negative 1, so we have a positive 2 here. And then we end up over here with 2x plus 1 minus 1, which cancel out, so we end up with 2x plus y. So this is our final factorization. Okay, number 5. The speed of the current in a whirlpool varies inversely with the distance from the whirlpool center. The Lofoten Maelstrom is a whirlpool located off the coast of Norway. At a distance of 3 kilometers, or 3,000 meters from the center, the speed of the current is about 0.1 meters per second. Okay, what is the speed of the current 250 meters from the center? First of all, we have to set up our general formula. Okay, this has told us that the speed of the whirlpool varies inversely with the distance from the whirlpool center. So our general formula is y equals k over x to the n, and that's this k is over x to the n because it's inverse variation. Well, it didn't say anything about varying with the square of the distance or the cube of the distance, so that means n is going to be equal to 1. So now our specific formula is that the speed is equal to some variable of some constant k divided by d to the first power, or just d, where d is the distance in meters, s is the speed in meters per second. Okay, so then we plug in 0.1, which is the speed in meters per second, equals k divided by 3,000, which is the distance in meters, which is what I'm choosing to use. So k ends up being equal to 3,000 times 0.1, or 300. So when I plug in, when I replace in our formula, the distance with 250 meters, I get S, the speed, is equal to 350 divided by 250, or S is equal to 1.2 meters per second. Let's change that to an N. Okay, and actually up here, let's change our other mistake that we made. Change this to a 2. Okay. So now the next thing we're asked is if the speed of the current is 0.05 meters per second, what is the distance from the center? So now the speed is going down, so we're going to assume that the distance goes up. So we set the speed 0.05 equals 300 over the distance, and we get 0.05 d is equal to 300. So d is equal to 300 divided by 0.05, which gives us 6,000 meters. So it's because the speed is much slower, the distance is much greater. Okay, number 6, we have a sequence. We start with 9, and it looks like it's arithmetic because we keep adding 0.07. So by the time we get to the nth term, we've added 0.07 n minus 1 times. So we'll say that a of n, which is the value of the nth term, is equal to 9 plus our common difference, 0.07, times n minus 1. Because that's what we're adding each time, and we've added it n minus 1 times to get from 9 to the nth term. Okay, for the next one, we also have an arithmetic sequence because we're subtracting 5.5 each time. It goes from positive to negative. So it's arithmetic with a common difference of negative 5.5. So we're going to say that a sub n is equal to 12 plus negative 5.5 times n minus 1, because again, we've added that common difference n minus 1 times. We could also say that a of n is equal to 12 minus 5.5 times n minus 1. Okay, the next one doesn't have a common difference here because subtracting 1331 minus 1210 and 1210 minus 1100 does not give us the same two answers. So, but when we divide 1210 by 1331 and 1100 by 1210, we do get the same number. In each case, it's equal to 10 over 11 or 0.909. So using the fraction, so I don't have any rounding error, I end up with 1331 times 10 elevenths, which is what I'm multiplying by each time, to the n minus 1 power, because by the time I've gotten to the nth term, I've multiplied my original 1331 by our common ratio 10 over 11. I've multiplied by that common ratio n minus 1 times. Okay, domino is 5 centimeters tall. A chain of dominoes is constructed such that each domino is 1.5 times as tall, wide, and deep as the previous domino. So we're multiplying the height by 1.5, the width by 1.5, and the depth by 1.5. Okay. The original domino we said was 5 centimeters tall. So what will be the height of the 10th domino? Well, the 10th domino, so the second domino, we've multiplied our original domino, the height of that by 1.5. For the third domino, we've multiplied by 1.5 twice. So by the 10th, we've multiplied by 1.5 9 times, or 1.5 to the 9th. We started with 5. We end up with 192.2 centimeters, or 1.922 meters, since there are 100 centimeters in a meter. Okay, if the density of each domino is the same, how many times heavier than the first domino will the 10th domino be? Well, now we're not just multiplying. So when we're dealing with weight, weight increases along with volume. So when we're increasing the size of these dominoes, not only are we increasing their height, we're increasing their width, we're increasing their depth, and so the volume of each domino is going to be not 1.5 times as great, but 1.5 times 1.5 times 1.5 times as great, or 3.375 times as great. Therefore, the weight of each domino is 3.375 times as great as the previous domino. So by the time we've gone from the first to the 10th domino, we've increased the weight by 3.375 to the 9th power, or 56,815. So our 10th domino will be a lot heavier than our first domino. Okay, the UN building is approximately 155 meters tall and is shaped approximately like a domino. What domino in the chain of dominoes is the first that would be taller than the UN building? Well, we are just going to be, again, multiplying our heights by 1.5 until we get to a height that is greater than or equal to 155. And actually, as it turns out, if we look at this group right here, these represent going from 0.05 meters multiplying by 1.5 each time, and eventually what we see is that we reach a height here of 166 meters. That's the first one that's greater than 155, and that happens at the 21st domino. So that's why we say it will be at the 21st domino that we finally find one that's greater in height than 155 meters. Okay, we're simplifying cube root of 40 times x to the 7th y cubed z squared. Okay, what we do here is we create two radicals. One, we pull all the perfect cubes and factor them out of our original radical, and then the other radical will just contain what's left over after we factored out. Largest perfect cube in 40 is 8, so we factor that out, put it here, which leaves us 5 because 8 times 5 is 40. Largest perfect cube in x to the 7th is x to the 6th. And again, we know that because 6 is a multiple of 3. So when we factor out x to the 6th from here, we're left with just x to the 1st, or just x. Largest perfect cube in y cubed up here is y cubed. So we factor that out, and that leaves us just 1 here. But since we're multiplying, the 1 doesn't change anything, so we don't write it in. Finally, the largest cube we can factor out is z squared. We can't factor one out of z squared, so we just leave z squared in this radical on the right. And so now we have these two radicals. If we were to multiply them together, we would get back up to 8 times 5 equals 40, x to the 6th times x equals x to the 7th, y cubed gives us the y cubed, and z squared gives us the z squared. But now on the left radical, we have a perfect cube, which we can then just take the cube root of, and again, another mistake, which is going to give us 2 times x squared times y. That's the cube root of 8x cubed times y cubed. And then that's multiplied by the cube root of 5x z squared. So now this has been simplified. And we're done.